All right, I think we're live. Hello everyone. My name is Mona Vernon. I head Fidelity Labs at Fidelity Investment, and it is a real pleasure to be moderating this incredible panel today for Boston FinTech Week. This is a topic that I personally care a lot about, and I'm just really thrilled to hear from this amazing panel. And so what we're going to do is have a really lively discussion around AI and bias, and then hopefully take questions from the audience. But to get started, I'd love to get some introduction to have you all meet our amazing panel. And so if Margaret, Ignacio, Laura, and Scott could give a couple minutes about your background and where you're coming from, please.
Sure. Yeah. Hi. I'm Margaret Mitchell. I am a computer scientist. My background is largely in natural language processing with some computer vision. And I've worked quite a lot on what's called ethical AI, or sort of operationalizing human values within AI system development. I worked at Microsoft Research for a while, and then I worked at Google Research for a while, where I started up an ethical AI team. And now I'm doing a whole host of things, so consulting and contracting for various companies, as well as starting to ramp up to join a startup called Hugging Face, where I'll be working on responsible machine learning.
Well, hi everyone. My name is Ignacio. I'm the CEO and co-founder of ARM. I have 10 years of experience in financial services, mostly in consumer finance, where I have worked a lot on compliance monitoring, making sure that consumers are treated according to the regulations by financial institutions. And my last 2-3 years have been focusing on vulnerable customers, which is a huge issue for financial institutions in the UK at the moment. And our focus is on identifying proactively early signs of vulnerability for those consumers, and help financial institutions monitor each step of the process so they can ensure or prevent any harm to the final consumer.
Hello, everyone. I'm Laura Kornhauser, co-founder and CEO of Stratify. Thank you so much, Mona, for bringing us all together today. Really excited for this panel. And thank you to the entire team that put together this amazing week, particularly the folks at FinTech Sandbox, which Stratify is a proud alumni of that wonderful program. So I have over a decade of experience in financial services, primarily at JP Morgan, helping both institutional and corporate customers build, structure, and deploy risk management strategies in public and private markets. And came together with my co-founders to found Stratify because all of us had experienced, I'll say, lending decisions that we didn't particularly think were fair. And we had a unique technology that we felt could solve the problem. So we help lenders accurately assess risk, but also do so with high levels of transparency. So focused on transparent machine learning solutions for credit and risk teams. Importantly, we also have an ability to both detect and mitigate bias from ML models that we're quite excited about, and I'll be able to tell you a little bit more about today. And thank you so much again for this opportunity. Looking forward to the panel.
Hi, everyone. I'm Scott Zoldi. I'm Chief Analytics Officer at FICO. I've been with the company for 23 years. So 23 years I've been focused on the applications of machine learning to real customer challenges, whether it be from a risk perspective, originations, fraud, and compliance. And throughout that time, I've authored about over 100 patents at this point, focused on unique machine learning applications required for the usage of proper and responsible use of machine learning in our financial services areas. For those of you unfamiliar with FICO, you may be familiar with something called the FICO score, right? We underpin lending in the United States and in many countries. In 1956, we were founded, and it was one of the first sort of applications of an AI at that point, a scorecard model, which is focused on trying to have automation and empirical sort of decisioning around lending decisions to remove the inherent bias associated with human decisioning. So it's a pleasure to be here today and talk more about how it's evolved.
Wonderful. So as all of you can tell, we have an amazing panel. I'm going to do a quick just shout out to the Boston-based FinTech Sandbox, which is a nonprofit that helps FinTech startups. And the reason I'm doing this is that Ignacio's current amazing startup, Automated Regulatory Monitoring, is a current member of the Sandbox. And as Laura said, Stratify is an alumni. So, you know, what would be helpful, I think, is just spend a few minutes kind of getting perhaps a rapid but a common understanding of what AI and the bias means. And I was wondering if Margaret and Scott can lead that conversation. So since we ended with you, Scott, why don't you start, and then Margaret can add on to that sort of baseline definition.
Yeah, absolutely. So in terms of bias and why it's such a big problem with AI, AI and machine learning models are problematic, right? There are a lot of excitement because they provide a lot of opportunity to improve decisioning and prediction. At the same time, they're largely what we call black boxes, which means it's very difficult to understand how the decision is getting made. And if you're not able to understand how that decision is getting made, then it's very difficult to understand whether or not you think that's proper and fair, and whether or not to test for it to be proper and fair. So bias can occur in many different ways. It could occur in the fact that the data that you've collected is non-representative of whom you want to score. It could occur because you're using information that you should not be using, so it's directly expressing bias as you train a model. Or the more tricky one, and the one that's a little bit more difficult, is as the machine learning model is put to task at trying to maximize performance, right? It finds nonlinearities that impute bias. Right? And those are typically what's hidden to the data scientists and to the business owners. And as a consequence, you know, the bias shows up usually as a disparate impact towards any one class of individuals. And so if you look at a class of two different groups of people, you might find that the model performs differently for them. And that's where the bias occurs. It occurs at a class level. And it's typically because there's not enough care around the development of the model and the monitoring of these models to ensure that bias doesn't occur. But it's not an easy problem, and it's typically not one that's only solved by a data scientist. It's one that requires deep process and a systematic way of addressing.
Yeah, I guess to follow up on that, Scott, I think basically covered it. I like to make a distinction between human cognitive biases and machine performance biases. So when people say bias, they often mean a few different things. One of the things they mean is like we have cognitive biases and we do things like racism and sexism. And when models take our data to learn, they pull up that racism and sexism. And so that's one kind of bias that we're talking about when we're talking about bias in AI. The machine basically learning these sort of cognitive things that we do that aren't great, that are problematic, and then propagating them. The other kind of bias that Scott also mentioned is about disproportionate performance. So it's common to evaluate a model and get one score, sort of like an accuracy score. It's actually not usually accuracy, but a performance metric. But another thing you can do is disaggregate it by different kind of subpopulations. So men, other genders, different kind of races and ages and things like that. And when these disaggregated values, these disaggregated accuracies are very different, then you have a bias. You have literally a difference in how the performance is across these different subpopulations. So those are the two main kinds of biases that people mean when they're talking about bias in AI. They're obviously super related. Inherent racism will mean inherently less information about some subpopulation, which will mean less good performance on that subpopulation. So there's a close relationship there in what's represented in the data and what the model learns. But at a high level, I think that's probably a good summary.
I think that's super helpful. So the next topic is really, prompted. I remember someone telling me like, AI ethics, that's really easy. I got it. And I was like, wow, this just doesn't seem like an easy topic to me. So what are, if you think about sort of demystifying the space of AI bias, like what are common misconceptions? and the ones that, make your skin, crawl, or things that you hear and you're like, okay, can we just make sure this is put to bed? So, maybe we start with you back, Margaret, and then we'll go to Ignacio, Laura, and Scott, and say, what's the one that most common one that you can't really take anymore? So.
Yeah, I mean, it's funny to hear like, oh, bias, I got that. I feel like if that's someone's response, they're really not quite understanding. I sort of think of this as a fractal problem where anything that you concentrate on explodes into different kinds of difficulties. So for example, say you're trying to look at bias with respect to gender. Well, how do you represent gender? Given a spectrum of genders, how do you get that out of the data? And is it even legal to get that out of the data, right? So actually addressing bias logistically is very complicated, even if at a high level you can sort of understand what to do. And each issue kind of subdivides into a whole bunch of other issues. But I would say my main sort of pet peeve or misunderstanding in this space is the model versus data debate. So people who like to work on machine learning modeling tend to say that bias comes from the data. And people who work on data tend to say it comes from both. And I would say the data people are correct. I think it's easy if you're working on something to pass off the problem to somewhere earlier in the pipeline so you don't have anything to do with it. But actually, like, we have experiments that show like data representation will affect the bias in the model, as will the loss function affect the bias output by the model. But I think people like to pawn it off to the data and just say it's only about the data. I work on optimization. It's sort of not my problem, but that's very much not true. It's the data and the model both working together that can learn and then amplify biases. So I think that's one of the most important things actually to keep in mind is not only is that there's like these lots of different sub-issues and things like that different stages in the pipeline of development will also give rise to different kinds of biases.
Ignacio, what do you see?
Yeah, so I think like to add up to Margaret's point, there's one thing that it shouldn't be that technical. I will say it's more on like the process side. One thing that I see is that people tend to think, okay, looking for biases is just like a one-off exercise, and yeah, I just like input my data into the model, then I look at the output, it looks good, so okay, it's unbiased, and they move on. That's not it. They should have strong policies and procedures to continuously look at the model, and also have people accountable for it. So Margaret was saying, okay, the data guys are, okay, this is not my problem, this is other guy's problem. It shouldn't be like that. There should be someone looking at the entire process and making sure that everyone is accountable for everything. And one example that comes into my mind when I look at this problem is Amazon's recruiting AI system, which once it was deployed, it was biased against female applicants. So obviously, if you look at this model tomorrow, it might be one day too late. And you can see the huge impact it may have. And when you look at financial and capital markets, when a nanosecond could cost you billions of dollars, you can imagine how impactful it will be if you just like look at it one time and just forget about it or you don't have the right people to look at the processes.
Yeah, I would say definitely dovetailing off of both what Margaret and Ignacio said. The very concept that I've got this, I think indicates a real lack of understanding of the problem, because it's not a point in time thing that can be just done and then you set it and forget it. It's got to be a rigorous process that's implemented throughout an organization that brings together stakeholders, not just from data science, but also from the business that will be actually using these models to help make decisions. They need to come around the table to both understand how they're going to define bias, because there's a lot of different definitions and a lot of different measurements associated with different definitions, and then how they're going to set up that framework for for not just testing before a model's deployed, but then also retesting once the model's in the wild and that model's in the production, and identifying those issues, before they get too far and make too many decisions that impact people in a negative way. I believe very strongly that transparency is such a huge part of being able to actually do that. I think one of the misconceptions, to bring in a new one that can frustrate me, is that complexity is always better. Model complexity should be matched with the problem that you're solving and the impact that problem has on people's lives, and then the associated level of transparency that problem requires. And in certain cases, sure, complexity is better. In other cases, simplicity that can bring with it a greater level of transparency and then therefore accountability is actually the right choice. And maybe you sacrifice, a sliver of, in some ways, hypothetical performance to get that added level of transparency, and that's well worth it as a trade-off to do. So making sure that the complexity of the ML that you're using and the way that you're developing and deploying it matches the problem that you're solving.
Scott, take us home. What are the common misconceptions?
So for me to layer on here, I think one major misconception is simply that if I don't use certain protected fields, right, then I must be ethical, right? And that's naive, right? I think part of that is understanding that a model is simply a reflection of the data and the society that we're in, right? And it's nothing more. They're neither good nor evil. They're going to capture what is within the data. The thing that I think is a common misconception is that you can design models that are going to try to avoid these sort of bias hiccups if you have things such around interpretable machine learning models. And so it's a common misconception that you can correct for bias when you're going to go employ things like deep learning models and gradient boosted trees and other things where the complexity is simply not sufficient, right? So I think the first thing we need to do is we need to ask ourselves, do we care about ethics? Do we care about explainability? That should inform what sort of algorithms we're going to use. When we use those algorithms, if we use interpretable ones, we'll know exactly what is driving the score and effectively what it would drive the bias, and we can monitor that going forward. The FTC has a great quote which basically says that it's not enough to build an ethical model, right? You need to be continuously monitoring it. I think that's already been addressed. But this concept of bias drift is super important, right? And that is much more important than the performance of the model. And just to give you a sense of how far we are from where we need to get to, we did a survey of chief analytics officers and machine learning officers and what have you, and only about 20% even monitor their models, right? So you can imagine where we are today if only 20% monitor models, and of those 20%, probably very few are actually monitoring for any bias or drift associated with models. So think about whether it's important, and that's going to decide. It's going to start you on a path of choosing the correct technology so you can actually do some of what my fellow panelists mentioned as best practices here.
Scott, you just introduced a concept I think that's really important, and I personally look forward to learning more about it, of bias drift. Did I catch that correctly?
Correct. Yep. Great. Yep.
No, that's very helpful, and I think because a lot of these deep learning models are so user friendly, there is just sort of like almost another element of usability bias where they're so easy to use. You think you got it, and I think that's also something that Scott's advice is really helpful to start understanding what are the key tenets one cares about, which is actually a good segue to say, how are all of you addressing or starting to tackle solving this problem? And so, I'd love to hear from some of the more recent enterprises, starting with Ignacio's, and then go to Margaret, Laura, and Scott, and hear how are you all thinking about that?
I guess for us, even looking at biases at the first time, we think about ethics because we are not using share prices for our model. We are using personal, sensitive information. So we have to be very careful about it. And I remember when I was in college, I had to discuss this use case in a marketing class, and it was about a company that was trying to solve the loss of 20% of poultry production in farms due to chickens killing each other by inserting a lens that blinded those chickens. So I remember my first two key takeaways from that class were: if you don't think this is horrendous, what kind of human being you are? And second, it was, okay, is this going to be acceptable for my personal ethical standards and society's ethical standards? So we first look at ethics, and I would say we have like a five-dimensional process. Ethics, the type of data that we're using, what's the impact. Also, we look at regulations. We are a European company, and we GDPR, so the regulation on data protection impacts us directly on how we use data and the checks that we do when we use that data. Then we look at data itself, and as we were discussing before, not only input data, making sure that we're not using protected characteristics by regulation, but also making sure that obviously the data is balanced. Then we look at the output data, and we look at certain metrics to make sure that results are correct. And we include functional roles into looking at the data output to make sure that the model is understanding the problem that we're trying to solve and the result that we're trying to get. And finally, the next step is look at the model. And we do that, obviously, we look at trying to avoid overfitting of the model. And also we look at fairness metrics to make sure that, and we look at different groups within our data. And also we try to look at the robustness of the model in different scenarios. And finally, as I was, if it wasn't clear enough before, we do this all over again. We have policies and procedures in place to make sure that we are following on the model, and we have people accountable for the appropriate performance of the model.
Margaret.
Yeah, I've been addressing this from a few different angles. One critical thing has to do with the culture of the business itself and what kinds of things can be discussed, what sort of stakeholders can be at the table. So that's more of a social, cultural focusing sort of problem, but it's really important to have inclusion when you're working on these kinds of systems, because that informs what sort of things you do and what inherent biases, the company itself puts in. So the culture around and improving that and creating inclusive spaces is really important. And so that's something I've worked on. I've been working a lot on data governance. So what it means to have data that's been informed by ethical values. So data that's consented, data where people have a right to contest their representation in that data. That's not done yet. Current state of the art is basically scraping the web. But what does it mean if you scrape something that's licensed or copyrighted? Those problems are not yet tackled. So I've been working on that, these sort of nitty-gritty aspects of what it means to have data and train on data. I've worked a bit on optimization functions, but there's actually a lot of people interested in that, and I tend to focus on the things that people find messier and harder. So I've only done a little bit of that, but some of the stuff you can do is helping to remove some signal. So Scott had mentioned that even when you're trying to not include something like gender, there will be proxies in the data set that the model will pick up even if gender isn't explicitly defined, such as the schools that have been gone to, or for race, it's often the zip code, things like this. And so you can build models that basically reverse the signal from that in order to make sure that those things aren't picked up as proxies. And then also working a lot on disaggregated evaluation, best practices in evaluation, what kinds of things to report, how to think through limitations and foreseeable harms and risks, and creating different kinds of evaluation data sets that will get at sort of these harder questions of if there are things like racism or sexism that your system has been picking up.
Great. So at Stratify, we are offering solutions for credit and risk teams that help them build, test, deploy, and then monitor machine learning models to help them make decisions like who to lend to or who to investigate for fraud. What we're really focused on and how we're addressing all of these problems is through providing a differentiated level of transparency in the solutions that we create, transparency that's really meant to bring folks around the table, key decision makers, key stakeholders, both in data science and outside of, such that they can understand how models are working and have the rigor and the governance behind that model development through deployment, through model in the wild, have that rigorous process built in to be able to, again, proactively identify these problems and do something about it. We also have a novel modeling approach that allows users to, automatically extract insights from data and information from data, but do so in a way that is fully transparent to the user, such that the user sees exactly what information was, if you will, extracted, and then can verify that before, again, going forth and putting that model into production. We find that this approach, it's something unique to Stratify, can be super powerful, especially in the problems that I mentioned where decisions are quite important. They're impacting people's lives, and you really need that level of transparency into exactly how the decision is made and exactly how the model works at an aggregate level. Kind of, sort of knowing is just not enough. And some other methods out there we don't think get close enough to the true level of understanding required for these types of problems. So that's something that we're doing to uniquely address these issues. Going to both Scott and Margaret's point, one of the ways that we help do this with bias in particular is by being able to identify within our model the root cause of a bias. And again, that typically does not come because a protected class is used as an input variable. People, I think, kind of know not to do that. But that's not how the bias often creeps into these models. It creeps into the, as other folks have mentioned, creeps into the data that is ultimately data from our past, which unfortunately has all sorts of bias all over it, right? So, and what we're able to do is help folks find the root of that bias, which is often comes from correlated variables, or interestingly, combinations of different variables that may not be so obvious when you just look at a correlation matrix and are looking at different variables that you may want to exclude due to the high correlation to a protected class. We're able to kind of get into the nitty gritty to identify some more complex interactions and make those visible to the user such that they can proactively mitigate that bias before deploying that model into production. So that's how we're focused on it at Stratify.
Scott, tell us about the topic. I know you've been working on it for a long time, and I'd love to know how you've thought about the evolution as you pioneered machine learning at FICO, and what are the big ways you're thinking about the future.
Yeah, thank you. So from my perspective, what we're focused on is this concept and the practical application of what we call responsible AI. Over the last couple of decades, I've been appalled by how open source and cloud computing and tens of thousands of startups have proclaimed that AI is easy and you push a button and you get a great model. And very often data scientists don't understand the algorithms they're using. They don't understand the implication of what their models could do in terms of impacting human life. And frankly, right, data scientists are not ethicists, right? And they do not speak for the entire company in terms of a ethics framework. And so this concept of responsible AI at FICO is something which essentially is a contract. It's a contract between data scientists and myself and the company with respect to how we develop models properly. So we want to make sure that that is established at the very beginning of a model development process, not checked throughout and not checked afterwards, or God forbid, not checked at all. And so what this means is that there is a documented model development process. We've been employing that for more than a decade and a half, and now we're formalized it around blockchain technology, so we actually have an immutable record of how models were built. But there are four major components to it. The first is the first of responsible AI is robust AI. Robust AI basically says, take the time to build it properly, understand the data, make choices about algorithms, ensure that things are balanced, have a good performance definition, and take the time to build it so that you ensure that a model is built correctly, it has the proper support, and it will be stable to changes in production environments. The second one is around explainable AI, and I like to talk about explainable AI as the good, the bad, and the ugly, where most of it is bad and ugly. There's a misconception that if I have a model that I can't explain, like a machine learning model, that if I apply an algorithm on top of it that I actually don't quite understand either, that somehow I'll get clarity to what's driving that decision. And that's typically not the case. And so explainable AI really is around understanding what drives that model, or the interpretation of what the model is, which allows us to understand what's driving the model prediction. It also enables us to get to the third part of this responsible AI process, which is ethical AI, focused on testing those latent features that are driving the outcomes for whether there's any sort of disparate impact across classes of customers. And if so, explicitly remove that from models, right? In today's technologies, you're not going to open source for this, but there's plenty of ways to prohibit imputed bias once you've found it and ensure that it doesn't show up in a model moving forward. And then the fourth point is audible AI. Right? It doesn't really matter if you build an ethical AI model. It only matters when it's used, right? So the building is interesting, but the use is where the damage is done to people's lives. And so audible AI is essentially understanding that we're not going to have a development process and a separate governance process, right? They're probably one and the same, where we're going to control data science artistry. We're going to abide by a corporate standard of what it means to develop models responsibly. And it's going to feed in directly to this audible AI, which means that we can go back and respond to regulators. We can understand what types of features are used and whether we think that's a good idea 2 or 3 years from now when that model is in production, or if we see the bias drift, right? We need to know what to look for, right? And we're going to do that by understanding that these are the 12 things that drive my model. And if I see them shifting in the wrong direction, since they're such that they're starting to show bias towards a predicted class, then I know that I need to make a change, right? Whether I disable that model, whether I move to a different model. And so for me, it's really around putting maturity around this. I've often said it's time for AI to grow up. There's a lot more process and software development than there is in data science today from a process and controls perspective. And so, I think this is where we're all going to head. I think it's essential, but that's a big part of what my focus has been in terms of addressing bias and ethics around this responsible AI frameworks.
I think that framework is really helpful, and I think all of you have, helped us understand the space and how you're approaching it. I thought it was really helpful. I love that you brought up this notion of maturity. In my mind, I often think about it as sort of this, wave of technology that hasn't gone through industrial robustness, and I think it really plays out when you look at how organizations are set up. And I think I'd love to actually segue this to the next question. But if data scientists are hired in a part of the organization, I wonder what does it mean for an organization that uses AI across all functions, and let's call it like a factory model. How is that becoming business as usual for everybody? That's such an interesting question. I think my experience is not showing that we're quite there yet. So the topic of maturity is particularly interesting. However, everybody's got to get started. So what would be helpful, I think, is, okay, what are 1 or 2 things that organization today should be thinking about to combat bias in AI? And what are 1 or 2 recommendations that you'd make to the attendees to kind of get that going? And then I think after that, we'll switch to taking some questions from the audience. I see them coming in. So let's get back to that in the same order. Ignacio, Margaret, Laura, and Scott, what are 1 or 2 things that organizations can do?
Well, the first that comes into my mind, and I think we've already talked about it, but it's continuous monitoring and having policies and procedures in place. The reason why I say this is because it helps you think about the risks and the consequences, and it helps you also think about how to prevent those risks and the impact and the harm that they could make. And another one would be to, again, look at your data deeper. Don't take that your model is working perfectly because certain metrics are showing up and they are within what you think it should be um, the case. There are a lot of deeper insights you can get from looking at the output data, looking at different groups to make sure that there are no certain bias against certain groups. Also looking at proxies for those certain groups that you're trying to prevent bias against. And so, yeah, those would be my two key points on if you're starting to do machine learning, look at those two things.
Yeah, I guess I follow up there. I agree with everything Ignacio said. I would say my sort of number one thing here to combat bias in AI is actually around diversity and inclusion. I know that's probably not an exciting technical answer, but I think a lot of people who have worked on AI ethics at the technical level have come to the same conclusion after digging through things, and that is the foundation of so many of the issues you see come back to who was at the table in the beginning, making the decisions about how these systems will be used, how these systems can be tested, things like that. You end up learning about bias when horrible errors happen. But we, sometimes talk about how, things are working well when you don't get a bad headline. But what helps you get there is people who actually have the foresight about how these things could be misused or drive disparate impact, as Scott mentions. And people who have had life experiences of disparate impact are going to be some of the best qualified to think through with that foresight about how these systems should be used. So, number one thing is diversity and inclusion, and so many issues are solved from there. And then the second thing I would say, I think echoing Ignacio a bit, is this rigorous disaggregated evaluation. So looking across different target groups, different subpopulations, genders, ethnicities, ages, whichever ones you can that are most relevant to your problem space. And making sure that that evaluation actually reflects usage, actually reflects difficult cases where it could get something wrong. Paying a lot of attention to what your evaluation data is and what it's showing you at the instance level in order to understand if you do see a disparate performance, what kinds of things are actually happening. So I would say those two things, diversity, inclusion, and robust disaggregated evaluation.
Yeah, I would say completely agree with both what Margaret and Ignacio said as far as key things. I think, one, organizations need to also make the decision that responsible use of AI is important to them and is a priority to them. I think, I'll say, I hope more and more organizations are making that decision and making that decision at the senior level, such that there is the resources allocated to address these problems properly. So I'll say that comes from the top and needs to happen. It's tremendously important and needs to happen before the bad headlines, to Margaret's point, so that companies can get ahead of those truly bad outcomes, not just for themselves and their shareholders, but also importantly for their customers, of course. And I think it's also really important to have a rigorous definition of what you mean by bias and what type of biases that you want to be focused on. And that should be by by the problem that you are solving using AI, right? And that there are a number of different definitions of bias. Those different definitions come along with them, different ways of measurement, and it's important to align around which biases are the focus, and have that diverse group of folks looking for what biases you should be aware of, and you should be proactively looking at and monitoring over time. I think that definition, the commitment at the senior level, and ensuring that you have a common understanding of what biases you could potentially fall into, and a clear definition of how to measure those, I think is tremendously important. And that comes from, again, having these checks not just at start and finish, not just at the daily level and the deployment level, but throughout the process, because bias can be introduced in all sorts of places throughout the process.
Scott, I'd love to hear your thought. One thing that just quickly came to mind is disaggregated evaluation. How incredibly important to understand the MVP rollout and what population is getting rolled out into. That oftentimes is not necessarily a consideration, but seems so incredibly important from what I learned from this panel. Scott, what are one or two things that you'd recommend?
Yeah, so I think the first thing I'd recommend is survey the problems that you're solving with AI, and start having difficult conversations. And those difficult conversations are around permissible algorithms and formal bias testing methodologies that will be used across an organization. In addition to that, right, we have to establish formal approvals and sign-offs by executives in the organization. Essentially, establish a chain of command. These problems are not going to be solved by data scientists by themselves, and many of them are under undue stress and pressure to try to make sure that they're doing things ethically. But it's really defined at a corporate level. So we have to define who are the executives in the organization that's going to sign off, right? And these things become real when people put their name against it and they sign off that it has been demonstrated to be ethical, and they have things in place to do so. We see too many pledges today in the industry about do no evil, right? And I would basically say prove it, document it, and audit it. We should not be trusting our entire business and the reputation of that business to either Sally or Sam. It needs to be a corporately defined sort of command and control. And also, understanding what are the throats that we choke when things aren't working appropriately, and that establishes accountability. Right now, very often there's not accountability in the organization, and it's easier just to say that data scientists are going to figure it out. But in reality, this is far too important of a topic for any organization. So I would say get the executives involved and start those chains of commands, and it'll become real really quick when they have to sign off on it.
I think this concept you brought up a couple of times, Scott, of defining the accountability seems to go hand in hand with this notion of going up the maturity curve with AI adoption. Would you agree? I
agree. Absolutely. Yep.
Great. So I think we got a few more minutes for questions. There's a couple that came in that I wanted to share with folks, and hopefully I can figure out where I pinned it. The question for you, Scott, that came in from Anil is, consider a person that's missed a payment a while ago, but had paid on time always and is saying and in full. How can AI bypass concrete algo equations and come up with, stuff happened and I'm completely going to ignore that missed payment, like some sort of notion of adapting AI or better than a concrete scoring system? In other words, can we leverage AI for good and come up with better, adapting it to understanding, that type of nuance? What do you think?
Yeah, so it's a good question. So very often, AI already accommodates for some of that. For example, a single missed payment where there's already been a really a good track record of payments. So sometimes it's already baked in there. But I will say that there is a whole advancement around adaptive AI technologies today. We actually use it in some of our models today, actually in small business lending, where the AI itself is constrained to adjust to differences in population dynamics. So you think about COVID and the pandemic, right, and payment waivers, right? It was an interesting dynamic here. Most people saved money, right? Now we have to deal with our debt crisis that we have in front of us this week, and in Washington, I believe, right? But generally, most people were under a very, very changed sort of environment, and so models that kind of look at what is the current dynamics of the population, so that it's not a dated sort of decision based on what credit risk looked like a few years back is super important. But I'd say, generally it's baked into most models, because if you have representative data, you have seen all those sort of environments of someone missing a single payment, but otherwise having a great history. But the future is around adaptive technologies, right? And ones that allow AI to adjust to the non-stationarity that is part of living in today's world.
Thank you, Scott. I was wondering, Denise on the chats brought this up, and I think you all touched on it to some extent, but I'd love to see maybe from you, Ignacio, and Laura, as you're building companies from scratch and have the luxury of organizing yourselves basically the way you want. How are you sort of thinking about this topic that came up about putting business people together with the data scientist, or trying to accelerate the maturity curve that Scott's talked about? Love to see how you're thinking about organizing yourself to set that up, and then maybe hear from you, Margaret and Scott, how you've seen it best, or are planning to sort of evolve how you're organized around that. So maybe Ignacio, then Laura, and then anything that you and Scott want to add.
Whew. That's not an easy question, to tell you the truth. There are, to tell you the truth, like one thing that probably is kind of like a disappointment for someone here in this panel is, they didn't look at the very technical, deep side of biases, and they didn't talk about metrics and all that kind of stuff. And that's because it's more like an art than science. It's a process to keep digging into the details to find what's going on with your model, and making sure it actually is going on with your model. And I think that approach from someone coming from the business side of the startup, I think it's ingrained in the company. Although we have data scientists working with us and doing all those calculations, I think I put a little bit more of a structure in our processes to make sure that the technical side is actually working.
Yeah, we're tremendously focused on that, both I'll say within our company and with the product that we're building. We really believe very strongly that the best models, best automated decisions are going to come from being able to bring stakeholders from across an organization together, and give them information about those models in a way that they can understand, and kind of meet each of those different stakeholders, whether it's the data scientist or a business person or a compliance professional. Try to meet them as best we can, where they are, and build a product that enables that effective collaboration and communication across those different groups, which are often siloed, especially at larger organizations, because in some ways they have to be, but believe that the a model is data is pre-processed, then a model is built, then it's thrown over the wall to other stakeholders is not really the right way to do it, and the right way to both maximize the efficiency and the fair outcomes that model can help generate. So we're really focused on how we can bring those folks together. And a key aspect of that is the interpretability and the transparency and the windows into models at an aggregate level and an individual, case by case or individual execution level. That is huge. Without interpretability, it's very hard to actually do that and kind of bring those different folks together around a model. And then the last thing I'll mention is that we believe strongly that bias is a KPI of models. There's a lot of different ways to measure model performance, and we see bias metrics and measurements as part of that performance metrics that should be looked at across a model.
Should I go, or Ignacio, did you raise your hand? Or?
Yes, I was just like, when I was hearing Laura, I just forgot to say one thing, and I think it adds up to something Margaret said and Scott said before me, and it's try to have conversations and try to get into your process people that faced that problem. And it builds upon the concept of not only leaving that to the technical side or the data scientist. We are trying to identify proactively vulnerability characteristics, and we've had a lot of conversations with organizations and people that went through that phase, and we've learned so much from them to improve our model.
Cool. So I guess I go next. I'll talk a bit about Hugging Face. So I've worked at two major tech companies previously, Microsoft and Google. And in both cases, I had sort of the daunting task of trying to, what I might call, retrofit ethical AI processes. And, it's a challenging task that is somewhat possible. But going to a startup gives you the opportunity to build an ethics-informed company ground up. And that means not only in terms of the sort of technical things, Hugging Face, I should say, is a tech company, but also in terms of the cultural things, right? So retrofitting inclusion in a company with already an established culture is very hard, unless you have top-down support from the CEO. Hugging Face, there is top-down support from the CEO. They're founded on the ideas of transparency and collaboration. So already their company had been based on key ethical values. And so I'm joining to do a ton of things, in part to operationalize ethical AI at scale. So that means that all models that they share have to come with transparent documentation on how well they work across different sorts of scenarios, across different sorts of populations. There's work I'm doing on sort of ethics-informed data, so people can evaluate their models in ways that are provided by Hugging Face, with that data actually informed by ethics-based collection processes. As well as, contributing to this open source sort of community where you can actually see the code directly, see where things might be going wrong, and actually make comments on the kinds of things that could be improved, or different areas where programmers' biases can come into play and things like that. As well as continuing my research. So it's very important to me that I continue to publish. So in addition to sort of working on these operationalization things ground up at Hugging Face, I'm of course also reading and publishing and trying to push the boundaries on what we understand about what it means to build a model with inclusion in place, or with diversity in place. What can that mean mathematically? And so, yeah, just sort of the world is my oyster over there, and we're doing a lot of cool stuff now.
Awesome. So we have about 6 minutes left. I'd like to give 5 of those to you, Scott, and then we'll wrap up. But I just wanted to hear how you've been thinking about it. I mean, I think many established organizations don't have the sort of depth of framework expertise that you have at FICO. So how have you been approaching that from an organizational perspective, and to kind of drive up that maturity curve?
Right. Yeah. So, we have focused really heavily around introspection of us as an organization, right? I mean, I think, I've been there 23 years, and I've seen a lot of evolution in the adoption of AI. We started off in the early 90s being one of the most successful applications of machine learning at scale, with the usage of neural networks in fraud detection models, as an example. And I think, what we've come to recognize through our business is that we have to constantly focus on the ramifications of models. And a few things that we have done organizationally and we continue to focus on are the following, and maybe just two, just to make it very concrete, right? The first is, I always talk about there should not be any analytic city-states, right? So think about Italy, and we should not have all these little city-states with all they have their own little says and their own little sort of views on the world and their own sort of governments around how they're going to implement. That causes confusion. Then you have, not the best practice. If you're lucky within an organization that has many different analytic actors and different analytic groups that are not unified, the very best you can hope for is an average result versus a world-class result. So unifying these analytic organizations are really important, and getting rid of analytic city-state behaviors or not invented here behaviors is really, really important, right? And it's hard when you have hundreds and hundreds of data scientists, all very smart, all with lots of ideas, but driving that to a single unified analytic organization is really important. Now, why is that important? Well, it's important because there has to be, it's like the Mandalorian. This is the way, right? There has to be one way of doing it. It can be challenged, it can be improved, right? But we can't get to best of state if we don't start from a written sort of set of directions or policies around how we develop models so we can improve it over time. And this will take time. It will take years and decades potentially, or longer, right? And so we need to start with that, right? And to not have those analytic city states. The other major part of this from a business perspective is that, we don't have a business without the very strong interplay between our business owners and our analytic teams, right? So FICO is an analytic company. We definitely appreciate this concept because we develop a model, it's used by others, it has to meet all these different criteria, and so our customers can leverage those models in their businesses. I think this was best described by a colleague of mine from MIT, Jordan Levine, who described it as a forced march, right? So think about the Marines, right? So we will force our business to engage with us and go through the model and go through what is driving this model and go through the results of the ethics. We will not stand for a situation where they will have plausible deniability around the fact that it's their shared responsibility that they are engaged in this topic. That's very difficult to do if you don't have a unified analytic organization. And so I think we start first by bringing our data scientists together and make sure that we don't have infighting and differences of opinions, and we're all aligned around how we're going to solve this problem, and understand that we may choose things that will advance and change over time. But then we are going to have to drive that message throughout the business, right? And take them through the forced march, right? And frankly, reviewing latent features may not be everyone's, favorite thing to do on a Friday afternoon. It's one of mine, right? But maybe not for the business. But I think that drives into other processes such as, QA checklists, GA checklists, model availability and deployment checklists that all are part of our software development processes, part of our GA processes. And, I think that's the roles that we're taking and all companies should be focused on. But first, get the analytic teams aligned and unified. And I think from there, you have power, you have a voice, and you can drive this within your organization, within the business. It shouldn't be the other way around, because the business may not be asking you the question. Or they may be satisfied with Sally or Sam saying they got this. Right, to your earlier point, Mona. Right, we got this.
Yeah, I think that's really interesting. It leaves me with 1,000 questions about, do you go through a cycle of federation and centralization, and that probably will keep all our friends in business school busy writing cases about that. So I think we have about a minute left. It might be a little tight to address all the questions, but there's one that came in, and maybe one of you would like to take it, and it came from Janice. I hope I did a decent job in pronouncing your name, but it was really a good question around, it looks like humans are disposed to bias, and that, bias is it's kind of a whack-a-mole challenge as you sort of solve for some, and society evolves and our norms evolve. How do we think about it? Is there a way that it can really be solved, or is really the answer just a continuous process? And like, who wants to take that and to take us home in 20 seconds, I guess?
I can quickly say that absolutely that's right. This is a constantly evolving thing, but one of the key points is to ground in the sources of biases, and that's subgroups with power differentials. So along race and gender and age and all these things we talked about, as long as you have that grounding, you can keep evolving the technology in light of the disparities that are being created across those groups.
Perfect. So thank you for all of you to making this session a masterclass in understanding AI and bias. We're really fortunate to have had this amazing conversation with you, and we'll see everybody in the next session. Have a great day.